So science and technology, generally you think, if it's about science, smart people involved. And so here we are at 7:30 in the morning, giving a talk. What's up with that? How did we ever talk ourselves into that? Listen, coffee in the back, and if anybody's going, if you fly, I'll buy, and I'll have a cup myself. So, hey, look, what I thought I'd do this morning is, first of all, David, thanks for that terrific introduction. It's the first time I've been called an accelerant, so that's good. And I'm really actually not, what I'm not is a technologist or a scientist. And so I come here today really to define a problem. And often I think that the conversation gets a little bit skewed because the community, whether it's the technical community or the personnel community or whatever, turns to Navy leadership to, hey, look for the solution. What are you going to do about this? What is your solution for this? And I've been trying to modulate that conversation such that, hey, I'm not the solution person. I'll define the problem. And then I want to bring you science, technology, industry, the experts into the conversation very, very early so that together we can come up with the best solution. In fact, I think that by isolating the Navy as the solution developers, this is how we get into these pickles with requirements that can't really be met, which runs up costs, schedule, risk, et cetera. And so if you think about some of the programs that we have been talking about lately, one is the MQ-25, Carrier Unmanned Aircraft. Just released the draft request for proposal yesterday. And the idea with that is to get industry involved. In fact, we've had them involved for some time in terms of, hey, show us the trade space here. What is the technological landscape so that we can find the knee of the curve, come up with a solution that has appropriate technical maturity, and put together a program that is about right on the risk curve, right? So that there's not too much uncertainty, too many unknowns as we go forward. Now, that will likely, that knee of the curve is not that exquisite solution that will last for the next 20 years. But that's not the model, right? So the model is, hey, we're going to do a lot better than what we've got right now. We're going to do that with a lot more certainty and confidence than we would if we're trying to project forward decades. And then we're going to build in, a much faster iterative process. So this will be step one, and we'll sort of design in modernization from the start. So I don't have to worry about lasting 20 years, right? Being that good. You tell me when it's time to take the next step, and we'll iterate forward another step. So it's almost this spiral development process, even for major programs. The other one we've got is the new frigate, and it's the same type of thing. We want to bring industry in, as wide a discussion as possible, as early as we can, to understand where the needs are in that family of curves that defines the technological trade space. Performance versus cost. Okay? So that trade space, the technological part, much better than we do. We're pretty good at defining our problem. And so that's the basis for our discussion this morning. And I want to get through my part pretty quickly so that we can open it up to questions. And that's always, by far the most interesting part. I guess the underlying thesis for my discussion is that we have, from my perspective, without a doubt, returned to an era of maritime competition. And I say returned because in many areas of our business, particularly sea control, blue water types of operations and warfighting, we have been uncontested for about 20 to 25 years. There has not been a challenge on the high seas for sea control, but those days are over. Right? We are back in competition. And that gives rise to a whole set of behaviors that we've got to change. All right, it's sort of like a company that, well, just read Clayton Christensen, right? These companies that have, near dominance in the market, almost a monopoly, they become big. There's a vulnerability to become complacent. The structures that arise in that environment become very bureaucratic, slow, burdensome, Byzantine, and you're very vulnerable to disruption, right? From a team that comes along that is hungry, that is lean, that is competing from the start. And so our challenge is, how do we restore that agility, that hunger, that leanness, that competitiveness? How do we come out of the off season and get back into competitive shape so that we can maintain our superiority, right? We're still ahead on the scoreboard, but my hypothesis is that the momentum of the game isn't in our favor right now, and we have to recapture that momentum. All right, and you just have to look around the world to see evidence of this fact. Right? As we speak today, there is an exercise going on in the Baltics, right? The Baltic Sea. We just finished our exercise in the Baltic Sea, ball tops, and it was on the neighborhood of 14 nations, very advanced exercise, 50 ships, number of aircraft. It included anti-submarine warfare. It included an amphibious landing, very sophisticated. That's not the exercise that's going on. The exercise that's going on in the Baltics right now is a bilateral exercise between the Russian Navy and the People's Liberation Army Navy from China. All right? They've got a destroyer up there and a frigate and some support ships, right? So that's new. That's a blue water capability that you can go around the world and do a exercise with a high-level warship, a very sophisticated warship, 180 degrees of longitude away. Okay? So they've done, the Chinese Navy has done a live fire exercise in the Eastern Med. Okay, so this is a global Navy. This is a Navy that is competitive. Okay. All right. In addition to the players changing, I would argue that the character of the game itself has changed since the last time we were competing 20 or 25 years ago. And so I'll talk a little bit about that changing character, because I think that's a much more interesting conversation to have with this audience than to talk about the geostrategic part. But of course, it's that intersection of strategy and technology, that's the interesting part for us. So we'll go ahead and get started. Okay, and we're going to start with a very familiar construct. This is Colonel Boyd's OODA loop, right? Observe, orient, decide, and act. And I would argue that for the most part, our superiority, our military superiority, has hinged greatly on the fact that we have been better at that first O, observe, than anybody else. All right? We have been more precise about understanding where our targets are, where our enemy is. We had better ISR, better sensors, better information than our enemies. And that allowed us to orient our plans, and that led very directly to straightforward decision-making and action. It gets complicated, but we had pretty clear superiority in our ability to see and locate with precision, targeting level precision, our enemy. I just read that SpaceX is on their way to meeting a very aggressive goal in terms of launching rockets into space, satellites into space. And you know this better than me, but there's this proliferation of sensors going into space, these tiny, CubeSats, and they've got pretty good imaging. They can't read your ID card or your driver's license from, low Earth orbit, but they can count cars, right? We can, and if we understand, so for instance, and that's why they're doing this, it's a commercial thing. So we understand that for a particular automobile manufacturer, their business model is such that within 3%, the number of cars that get offloaded at Long Beach, that's their sales. And if I've got a little piece of, I've got on-demand imagery of that loading dock, and I've got a piece of software that will count those cars for me, then I can track the business gains or losses of my competitor. It happens automatically, right? That's pretty good tactical data. I can't read the license plates on those cars, but I don't need to. There's plenty of information. And oh, by the way, there's not a person involved, right? It's all done with image processing software, okay? This is sort of the trend. Think about the number of surveillance cameras that followed you on your way to this conference this morning. This idea of sensing is becoming ubiquitous, and it's shifting the competitive space in this OODA loop, okay? So that no longer are we competing, or are we superior in that first O, the ability to observe. That's becoming a very level playing field, and the competition now is shifting to what do I do with that information? How do I manage that, petabytes, or however you want to characterize it, that avalanche of data, all right? And so this is the challenge that's before us. We're moving, I think, from an era that has been defined by superiority and our ability to precisely define a target to an era where it's not about precision, but it's about decisions. How do you sort through that, sift out what is normal, what is abnormal, how do you respond to the abnormal and make a decision that will lead to action? All right, so this is our challenge in the Navy. That is my problem statement. And the way we get at that is through a combination of things. So I think it's Navy and Marine Corps after next is sort of the theme of the conference, which is good, except that we got to get the next Navy first. And so we'll talk a little bit about that. There's been a number of studies that we've commissioned. We've done some studies in the Navy, and there's been a number of other people that have done studies that talk about, what sort of Navy is needed to meet our national responsibilities. What sort of Navy does the nation need to continue to be able to defend itself from sea and also protect our interests around the world, maintain our prosperity, access to markets, access to trade routes. And this slide just sort of roughly depicts the sum or the superposition of those studies. And they have all pointed to some Navy in the size of, sort of the mid-300s in terms of numbers of ships. And so this shows, a couple of those studies. One is the our force structure assessment. One was done by MITRE, one was done by CSBA. You can see the current, or at least the 17 budget, pretty good divergence there. And so that's our problem. How do we manage that gap? And even under the most, I guess, traditional shipbuilding profiles, right? If we just sort of kept building ships at the profile, the rate at which we do right now, you can see that we get out to 350 somewhere in about the late 2030s, which is way late to need, right? We need to get sort of this equivalent naval power but we need to get it in the 2020s. That's the decade of competition for us. And so, there's one slide that sort of defines our challenge. How do we get this level of performance out of the Navy, but get up there quicker so that we're reaching that low amount of naval capability, naval power in the 2020s by the late 2030s, okay? Who knows what the world's going to be like in the late 2030s? And there's an awful lot of academics and naval strategists, et cetera. We can argue about whether it's 350, 351, 355, but it's all really a pretty tight cluster around that mid-300s. And so we'll let that discussion ensue, but as the person who's consumed with building maybe not the Navy after next, but maybe just the next Navy, I'm saying let's get building. Right? All of the estimates, all of the assessments say it's bigger than we are right now by a significant amount. And we've taken a look and coordinated and engaged the industrial base, and they're ready for this challenge. Right? If it's amount of platforms, we could probably build 30 more ships than are in the program right now in the next 7 years. If it's amount of aircraft, hundreds more aircraft. I mean, the industrial base is ready to handle this challenge. Just have to make sure that we can resource it. Okay, so we'll continue to move forward. How are we going to do that? How are we going to get to this Navy we need in the time that we need it? And I'd propose that it really is kind of made up of 3 major components. All right, and we'll try and talk through a fairly simple representation of those 3 components. So one is just the number of things, right, platforms. And so we've got a graphic here that illustrates, a number of platforms. And so those are the black icons. And then you can see these circles around each of the platforms. And that's kind of just a simple representation of the capability resident on that platform, right? It's sensors, weapon systems, combat system, power, propulsion, et cetera, okay? And if you think about describing, the current fleet, it is sort of a linear graph that you increase naval power as you increase the number of platforms with their resident capability, all right? So one way to increase naval power is simply to build more platforms, and there's a nice broad consensus about the need to do that. And so let's go to a different graphic. Now we have more things, and they have their inherent capability. And so if you sort of go to the extension of that in terms of the naval power, you can see that, it's sort of along the same trajectory, but you got more stuff, and so you've got that much more naval power, all right? So that's a fairly simple way to increase naval power, is to build more Navy, more platforms. So that's one way to do it, and there's no denying that, what's the phrase? Quantity has a quality all of its own, right? And there's validity to that, particularly as you think about where we need to be to protect our interests. We're a global maritime nation, okay? And we need to be places, and it takes numbers to do that. Okay, so let's keep on going. Second component of increasing naval power is to increase the capability of each of those platforms. All right, so you put better sensors. You just saw the little video clip that talked about the LAWS, right? The laser weapon system. It was funny because they really made a point of highlighting that laser travels at the speed of light, right? Does everybody get that? Okay, it's because it actually is light, right? That's why it travels that fast. But anyway, if you think about increasing the capability of each of those platforms, and that's represented here by sort of bigger circles around each of the platform icons, then you can start to think about sort of increasing the slope of that curve, right? So for each platform, I get that much more capability, and you start to see how that manifests itself on our, admittedly simple representation of naval power as a function of platforms. All right, so the last part, the third component of naval power as we are thinking about it, comes from now how do all of these platforms operate together, all right? And in the extreme, in sort of the theoretical limit, I would want to network everything to everything, okay? And there is a great, sort of a dominant theme in certainly the technological community, but also the strategic community about, one thing that's different about our current competition is that it is moving a lot faster, right? The pace of change has really taken off. And the descriptor, the word that's used to describe that pace more often than anything else is exponential, okay? And you've all very familiar with Moore's law and all of these exponential types of laws or curves that have, that's the trajectory that we've been on in many ways. It works at sea as well. Think about this. Very smart team, and by now you've had a couple of sips of coffee. How long have we been going to sea as, humans? Somebody want to volunteer? 30,000? Okay, that's not bad. You could probably defend that, 30,000 years. 10,000 years you can easily defend, right? You can find archaeological evidence that it's been, 10, 20, 30,000 years that we've been, that's when mankind first went to sea. And so think about, another graph that starts with 0 ships at sea 10,000 years ago and kind of, plots the amount of traffic at sea over time till today. In the last 25 years, that maritime traffic has increased by a factor of 4. All right? That's remarkable. If you think about that, the hockey stick shape of that curve, right? Whereas it's just this gradual increase over 10,000 years, and in the last 25 years, you see this spike of times 4, right? That shape, the shape of that curve goes throughout the maritime. The information world that we talk about, well, that world, that information world, most of that traffic, the international traffic, that flows on cables that reside on the ocean floor. So the maritime is right in the middle of that information technology, the information world. We talk about a cloud, and we look up because that's where clouds are. But all that information's down on the ocean floor, right? We should be talking about a sea of data, not a cloud. So henceforth, no more cloud talk. Right? It's about sea, the sea of data. All right. The Arctic ice cap is as small as it has ever been in our lifetimes. Okay, and that's opening up trade routes. That's opening up access to continental shelves and their attendant resources. Things are moving very fast at sea. If you think about the amount of food we get from sea, right? Both protein and carbohydrate. In that same 25 years that maritime traffic has quadrupled, the amount of aquaculture, the food we get from the sea, is over 10 times, is increased by a factor of 10. All right, megacities. There's 31 megacities in the world today. In the next 10 years or so, there's going to be another above 40, and the vast majority of those megacities are on the coastline. So you can see this tremendous amount of change, not just in information technology, but also in our business. And so you can picture this exponential curve. when you start thinking about networking these platforms together, it's not exponential, right? It starts to become a matter of combinatorics. How many different ways can you combine all of those things? Okay, how many different combinations, unique combinations do I have? That's kind of a factorial type of a curve. And I don't have this talk with too many audiences, so, but you know, if you plot a factorial versus an exponential, the exponential looks flat next to a factorial curve, right? I mean, that can really take off very quickly. And so I would argue that when you start to network all of our platforms together like this, you start to depart from the linear, okay? And you start to see naval power increase in nonlinear ways, okay? And these three things, the components of naval power, the platforms, the systems and capabilities of each of those individual platforms, and then the networking of those platforms together. That's how we're approaching naval power. Now, what's the Achilles heel in taking this argument? Anybody want to offer a guess? Sir? Yeah, exactly right. So, in fact, that's how Admiral Hahn opened up, right? We talked about a network of people. And so I would argue that all of my graphs, let me see if I can do this. There we go. That graph is flawed in some fundamental ways. And I think it would probably look more like this, right? And so now you're talking about, you know, it doesn't go down to zero with platforms. As long as you have trained people, you've got some capability. And everything departs from that. And the area under this curve really describes, you know, naval power. And that is enabled by trained operators who have to use all of this equipment, use those platforms, use that capability, use those networks. And so you've got to do all this with people in mind. We kind of got out ahead of ourselves in the submarine force on this. We came up with a very slick way to improve our combat systems and sensors pretty quickly, right? And we used a lot of commercial off-the-shelf gear, and we could do it pretty much every 4 years. We could refresh the hardware, and every 4 years we could refresh the software, and we just sort of did them, you know, we interspersed them so that every 2 years you were either getting a hardware or a software refresh. And a couple things, you know, kind of hit us upside the head after a few years of doing that. One, you got to manage it across the force, or you're going to have about 500 different configurations of combat systems and sonars out there. So that's hard for a force to manage. And two, even on that one submarine, one platform, you've got to make sure you know, the refreshed software and hardware has to have some connection to the last version. Otherwise, you're always sitting your operators down in front of something that is brand new, or that they don't understand and can't use. And so this whole approach has to start with people in mind, the operator and the decision makers in mind. Otherwise, all of this will sail off, and we will never achieve naval power, because the people that bring that about will be lost in the shuffle. Okay, so let's go back to our OODA loop, and we're going to put it on its head here real quick, and think about now, you know, what are the implications of the discussion we have with this shift from, you know, observing to orienting and deciding, and, you know, that future Navy that we talked about. More platforms, more capable platforms, and much more network platforms in this emerging era of ubiquitous sensing. And so we're moving towards a scheme which really treats sensors as a service. And service to who? Well, a service to the operational commander. And who is the operational commander and what do they command? Well, that depends, all right? But it's got to be scalable, down to maybe one pilot in a cockpit of an aircraft, okay? Or maybe it's the fleet commander, okay? But so the fleet commander will have all of the sensors in his AOR, her AOR, at his or her disposal, okay? If you're properly networked too, certainly all the platforms, the blue platforms, are at that fleet commander's disposal as well. And on those platforms are payloads. And so now you've got a system where, hey, I've got connectivity to all of those payloads. It's a service approach to payloads, all right? And the tricky part is in the middle, is how do I take that tremendous amount of data from all of my sensors, my service of sensors, and connect it in the most effective and efficient way to my payloads, which are going to be the thing that I use to influence that environment. And so now you start to see the challenge for all of the science and technology world, right? What do I need to do that? What are the technologies that would help me build more platforms, make them more capable, and then certainly do this better than any enemy? Orient and decide. And my thought is that there's tremendous implications for this. You know, what does deception look like in this world? I'm a sucker for sports analogies, and so the question would be, if I'm going to get ready for Sunday's game, how does that change when I've got my opponent's scouts watching all of my practices all week? Right? Tremendous challenge, but it's a challenge that's on us. It's getting more and more difficult to find ranges and places that we can do exercises, that we can practice without being observed. All right, so this is something we're going to have to wrestle with. And so I hope that I've been at least somewhat effective in defining a problem. And I look forward to the discussion later on this morning, just in the next 30 minutes or so, and in particularly over time, as we work together in meaningful conversations at the appropriate time to define how we step into this future in a way that's affordable, that has appropriate technological risk, and you know, I've got a sense of confidence that I can deliver this, all right? So thank you all very much.